Okay, so this is my presentation for 8Keep, which is in my 327 project. Basically, it's just a mechanical keyboard that has an 8 kilohertz polling rate, which means that it communicates to the computer at 8,000 times per second, which compared to like a regular Bluetooth connection, which operates at 250 hertz, results in a lot lower latency, so less delay, and overall it just feels more responsive, which is really good for applications like gaming and things like that. And so I included a little image or diagram of the components that I'm making. So one of the cool things about this project is that I designed it so that the PCB could also be used as a plate to hold the switches in. And so you can see the mechanical key switches are right here within the case. So this is sort of like from a side view of a mechanical keyboard. And the PCB is either soldered or the switches are either soldered to or put in sockets on the PCB. In this case, I'll be soldering them. And so one PCB will be able to be used as both the plate, or not one, but two PCBs will be able to be used as the plate and the PCB for one keyboard. And so some components that I chose for this, I chose the NRF 5340 microcontroller, which has Bluetooth, Wi-Fi, and 2.4 gigahertz radio built into it so that I can just write my own custom radio code if I wanted to. I also chose some switches that I harvested from a vintage keyboard that I've been meaning to put in a keyboard and design a PCB for. Um, and then also the NPM 1300 power management IC, which includes a battery charger, a buck regulator, um, or a buck converter, sorry, and a voltage regulator for converting the 5-volt USB power down to 3 volts MCU. And it also has a fuel gauge, which I'll have to program myself, and then 3D printed case. So I did some prototyping with a 3D printer, and it had very, very good results. So here's a picture of the PCB so far. This is the bottom side. You can see all of the switches or the footprint for the switches, and they're all spaced properly for a keyboard. And then there's some stabilizer cutouts as well as some footprints and stuff for the other components. So all of this stuff at the bottom or towards the left side of the space bar is the power management IC, as well as two connectors, one for the battery and one for the USB-C breakout. And then the other stuff towards the right of it, that is the microcontroller module that I'm using. Oh yeah, and you can also see the little board cutouts for the switches, which allows me to just like rock the um, this little square back and forth until it snaps out, and then that'll just be a little space for the switch to fit snugly inside. So that's the plate part. And then design process wise, I am behind schedule compared to what I wanted at the beginning of the year, but I'm still ahead enough that I can comfortably finish the project by the end of the year. So I wanted to get the PCBs ordered a week or two ago, but I just got them in at the beginning of this week. And then also I still need to desolder all of the switches for the board. Um, and yeah, I think there's quite a bit of stuff that I have left to do, but most of the things that I need, like in terms of resources or support from this class, will be definitely finished by the end of the year. So the rest of the stuff I could either finish sometime else, or I could just hold on to it until I work on it again. So this would be, for example, like the firmware. So I could always just write new firmware and upload it. And also printing out a plate or a case, which that's more of a luxury because the keyboard already has the option, or the PCB already has an option to just be a plate in and of itself. And other than that, I just need to assemble the PCB, desolder the switches, and also make this small testing board so I can write the firmware without having the actual PCB on hand yet. And then design choices wise, the only major design change that I had from the beginning of the project was just the USB receiver. Originally, I wanted to design a custom board to um, be able to use the uh, 2.4 gigahertz proprietary radio communication between like a receiver that's plugged into a computer and then also the microcontroller that's on the keyboard. But I realized I already have two dev kits. So I might as well just use the dev kit as the USB receiver because it already has a USB connection on it. And while this is technically using a $50, $60 dev kit as just a dongle, I don't think this is going to be like the end solution, but this will help me a lot in terms of prototyping and figuring out what exactly I need for the receiver to work. Other than that, everything else will be kept the same in terms of my goals and the choices that I made. So I've learned quite a bit. I've learned how to model stuff in Fusion and also 3D print. So I did my first ever 3D print a couple days ago, and it turned out very well. And then I also learned how to add cool silkscreen graphics in Altium. So I did this in Eagle, but I also figured out how to do it in Altium, which is why there's this little panel here. And then also I put this one on the front of the board, and we're going to see how this one turns out. Other than that, I mean, I've been talking to people about the project, and I've lately been talking to people that don't really know much about custom keyboards, but they use like keyboards a lot, either for gaming or for their jobs, and so they have a lot of experience with the end product. And so they thought that the project overall was super cool. A lot of praise for the PCB, but there was also interest in different case designs and modifications for the case, keeping the PCB the same. So, for example, having the ability to attach or detach a wrist rest, or having different typing angles, or having weights inside the keyboard so it won't move around as much. And so there was also a lot of emphasis on software experience so that they can reprogram, going back over here. So this is the back side. So this would actually be on the left side of the keyboard, this two column, or these two columns of switches over here, being able to reprogram those to suit whatever function they need. So there's a lot of emphasis on making sure that the software is up to par. But other than that, I mean, I do have a few questions. So how do you go about combining PETG 3D prints? Because I know for ABS you could use a mixture of acetone to sort of glue things together, but is there an equivalent way to do that for PETG? This is because I don't really have the option of using super strong joinery, just because the parts that I'm making, for example, like the plate, are relatively thin between the holes. And so I'm not really trustful of being able to put all of the force onto those tiny little joints if I were to make them like that. Uh, Other than that, I mean, is there anything else that I should include on the keyboard while I work on the next revision? So I already included RGB underglow for this one. Maybe I should throw in like a knob or something. We'll see. And then what other images should I put on the PCB if I do make a revision? So now that I have the power to just add whatever graphics I want, is there anything else that might be cool to have on a PCB? So yeah, I mean, that's all. I look forward to your responses, and thank you.